Have you ever been totally convinced by a single piece of evidence, only to find out you were wrong? Well, today, we're going to tackle Bayes' theorem. It's a really powerful mental tool that helps you weigh evidence the right way, and honestly, just think a whole lot smarter. Let's dive in. Okay, to see just how easily our own intuition can trip us up, we're going to start with a classic brain teaser. Just imagine for a second that you're on a jury trying to solve a hit-and-run case. So here's the big question. A witness saw what happened, and they're pretty certain the taxi was blue. Based on that information alone, what do you think the probability is? Seriously, take a second. What does your gut tell you? All right, now here are the two crucial facts you've got to work with. On one hand, the witness is pretty reliable. They get the color right about 80% of the time. But, and this is a big but, most of the taxis in the city are actually green. Only a small fraction, just 15%, are blue. So how do you balance what the witness saw with the reality on the ground?
This right here is what you could call the evidence trap. Our brains are just naturally wired to pounce on new, specific information, like a confident witness pointing a finger. But we often get tripped up when we have to combine that with boring, general background info.
So if you guessed 80%, you're in good company. That's what most people say. But it's not the right answer. In fact, the real probability is way, way lower. And understanding why reveals a really common flaw in the way we all think.
This is a classic thinking error called the base rate fallacy. We just latch on to the exciting story, the 80% accurate witness, and we tend to downplay, or sometimes totally ignore, the starting information, the base rate. We just forget that seeing a blue taxi in the first place is actually pretty rare.
So how do we fix this? How do we fight against this mental shortcut? Well, this is where our amazing tool for the day comes in. We need a structured way to take what we already know and update it with new evidence. We need Bayes' theorem.
Now, before we get to the theorem itself, there's just one super simple idea we need to get our heads around. Conditional probability. All it means is the chance of something happening, given that something else is already true. So for our puzzle, what's the probability the taxi was blue, given that the witness said it was?
And that is the magic of Bayes' theorem. Don't let the formula scare you. It's really just a formal recipe that lets us calculate that exact conditional probability. It gives us a step-by-step way to blend our old knowledge with new evidence to get a much more accurate belief. Let's break this down real quick. The prior is just your starting point, what you believe before getting any new info. For us, that's the 15% chance any random taxi is blue. The likelihood is the new evidence, in this case, the 80% chance the witness is right. And the posterior, well, that's the shiny, updated belief that we're trying to figure out. All right, theory's over. We've got the framework. Now let's actually roll up our sleeves and apply this thing step by step to finally solve our hit-and-run mystery. Okay, let's walk through the math. Don't worry, it's pretty straightforward. First up, we figure out the chance the taxi was actually blue and the witness correctly saw it as blue. So that's our 15% prior times the witness's 80% accuracy, which gives us 12%, or 0.12. Now for step 2, and this is the really important part, we need the total chance the witness would say blue for any reason. This can happen in two ways. They saw a blue taxi and were right, or they saw a green taxi and were wrong. We already know the first part is 12%. The second part is the 85% of green taxis times the witness's 20% error rate, which is 17%. Add those two together, 12% plus 17%, and you get 29%. Finally, step 3. We just divide our result from step 1 by a result from step 2. And there it is. The probability that the taxi was actually blue, given what the witness said, is only about 41%. That's less than a coin flip. It's so much lower than 80%, right? Even with a reliable witness, that really low starting number of blue taxis, that base rate, pulls the final answer way, way down. Let's do a super quick round to make sure this sticks. This is a classic medical scenario. Imagine a rare disease. Only 1% of people have it. The test for it is 99% accurate. So if you test positive, what's the chance you actually have the disease? Come on, your intuition is probably screaming 99%, isn't it? But you probably guessed it by now. The real answer is just 50%. It's a coin toss. Even with an incredibly accurate test, because the disease itself is so rare, that low base rate again, a positive result is just as likely to be a false alarm as it is to be the real thing. It's the exact same logic as our taxi problem. So, look,
The big takeaway here isn't just about solving riddles about taxis or medical tests. This is a fundamental way to approach any new information and start refining what you believe to be true about the world.
You can really think of it like this. It's a system for thinking. It forces you to start with what you already know, that base rate, and then systematically adjust how confident you are based on the strength of any new evidence you see. It really is the engine of rational belief updating. And that brings us to the final question, a challenge for you, really. Think about something you believe pretty strongly. What's the starting probability, the base rate? What's the new evidence you've seen? Applying this kind of thinking can really challenge our assumptions and get us a little closer to an accurate view of reality. So, what will you re-examine?